Magandang umaga, hapon at gabi sa inyong lahat. I am Charles Kenneth A. Famor, and today we are going to discuss about solving trigonometric equations. Pure mathematics in its way, the poetry of logical ideas by Albert Einstein. Trigonometric equations plays a fundamental role in mathematics, physics, and engineering, as they describe periodic phenomena such as sound waves, light, and mechanical vibrations. Solving these equations involves finding the values of angles that satisfy given trigonometric equations or expressions. Trigonometric techniques, including algebraic manipulation, identities, and inverse trigonometric functions. Understanding these methods is essential for application in real-world problem solving, from architecture to astronomy. Let us begin with this example. So example 2, we have solving trigonometric equation using zero factor property. So we're gonna solve sine theta and tangent theta is equal to sine theta over the interval of 0 degrees to 360 degrees. So solution: sine theta tangent theta is equal to sine theta. So this is the original equation. So we have to subtract sine theta. So we have to subtract the left equation, the 2 with sine theta. So therefore, our answer would be sine theta. Then equals to sine theta and open parenthesis tangent theta minus 1 close parenthesis equal to 0. So we gotta factor out sine theta first. Then we will have sine theta is equal to 0, or tangent theta is equal to minus 1 is equal to 0. So we're gonna have to use the zero factor property. Therefore, tangent theta is equal to 1. So the theta would be the theta would be 0 degrees, or 180 degrees, 45 degrees, or 225 degrees. So we gotta apply the inverse function. So the solution would be 0 degrees, 45 degrees, 180 degrees, and 225 degrees. Okay. Next, we have another example from the book, which is in a quadratic formula. Okay, so we have to solve for cotangent x, open parenthesis cotangent x plus 3, close parenthesis, is equal to 1 for all solutions. Okay, we have the solution. We have to multiply the factors on the left and subtract 1 to write the equation in standard quadratic form. So as we can see here, we use the distributive property. So we have multiply the cotangent x to cotangent x inside the parentheses, and we multiply the cotangent x to 3. So therefore, we have the cotangent square x plus 3 cotangent x minus 1. So we have to subtract 1 to it. Okay, this equation is quadratic in form but cannot be solved using the zero factor property. So we cannot use the zero factor property. So therefore, we must use the quadratic formula with a is equal to 1, b is equal to 3, and c is equal to negative 1, and cotangent x as the variable. Okay, we have the cotangent x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So this is the quadratic formula. Okay, so then we have to substitute it. Okay, so we have the equal to negative 3 plus or minus of the square root of 3 positive negative of negative 3x squared minus 4 times 1 times negative 1 and over 2 negative 1, because we are using the a equals to 1, b is equal to 3, and c is equal to negative 1. So we are using the quadratic formula again. So we have to simplify it. So the answer would be negative 3 positive negative square root of 9 plus 4 2. And then we have to continue it. So we have to add the radicals. So therefore, the answer would be negative 3 positive negative square root of 13 over 2. And then we have to solve for it So first, we have to solve for the cotangent x is equal to negative 3.302775,638, or cotangent x is equal to 0.302775,6377. So we have to use a scientific calculator for this. So x is equal to cotangent raised to negative 1 is equal to open parenthesis negative 3 dot point 30277563 8, or we have the other value for it. So the definition, this is the definition of the inverse cotangent. So again, we have to write this down. X is equal to tangent tangent raised to negative 1. So we have to in order to get the inverse, so we have to just flip it over. So we have to put the one numerator for it. Then we have to plus the pi. For it. So therefore, our answer, by summing all that, our answer would be the value of x is 2.84759135 and 2. So that's the value of the x of example 4. So to find all solutions, we add integer multiples of the period of the tangent function, which is pi, and to each solution found previously. Although not unique, a common form of the solution set of the equation, written using the least possible non-negative angle measures, is given as follows. So this is the solutions. So 2.8476 plus n pi, comma, as 1.2768 plus n pi, where n is any integer. So we have to round. We have to remember that we have to round to 4 decimal places. Okay, so we have the last example, which is solving trigonometric equation with squaring. Okay, so solve tangent x plus square root of 3 is equal to secant x with the interval of 0 and 2 pi. Okay, so the solution, we must write the equation in terms of a single trigonometric function, because the tangent and secant functions are related by the identity 1 plus tangent squared x is equal to secant squared x. Square each side and express secant squared x in terms of tangent squared x. Okay, so we have to square each side. So we have to square the tangent x plus plus square root of 3. We have to square for it. And then the second x also have to square for it. Therefore, the answer would be tangent squared x plus 2 plus 2 with the square root of 3 x plus 3, and then equal to secant squared x, because what we are using here is x plus y squared is equal to x squared plus 2xy plus y squared. So that is how we solve for it. Okay, and then we have to use the Pythagorean identity, which will give us tangent squared x plus 2 with 3 square root of 3 tangent x plus 3 is equal to 1 plus tangent squared x. So that is the Pythagorean identity of it. And then we gotta subtract 3 plus tan square x. So the answer would be 2 square root of 3 tan x is equal to negative 2. So, and then we have to divide 2 square root of 3. So the answer would be tangent x is equal to 1 over negative over square root of 3. Sorry, I keep saying negative. Okay, then and then we have the tan x is equal to negative 3 squared square root of 3 over 3. So we rationalize the denominator. Okay, so solutions of tangent x are 5 pi over 6 and 11 pi over 6. So those possible or proposed solutions must be checked to determine whether they are also solutions of the original equation. So we have the checking here. Tan x is equal to tan, so open parenthesis. So we have to substitute the value of the x, with 5 pi. First, we have to get the 5 pi over 6, and then we have to get the 11 pi over 6. So we have this 5 pi over 6 first. Okay, so we solve for it. Let's just move directly here from negative square root of 3 over 3 plus 3 square root of 3 over 3 is equal to negative 2 2 square root of 3 over 3. So 2 square root of 3 over 3 is equal to negative 2 over 2 square root of 3 over 3. So it is false. So therefore it is not it's not equal. So therefore it is false. But here in the 11 pi over 6, we get that we get negative square root of 3 over 3 plus square root of 3 over 3 equal to 2 square root of 3 over 3 is equal to 2 square root of 3 over 3 equal to 2 square root of 3 over 3, which is true. As the check shows, only 11 pi over 6 is a solution. So the solution set is 11 pi over 6. That is the solution set only. Okay. So we have to consider this, no? So we have to keep in mind this is our key points. So in solving a trigonometric equation, first thing we need to do is we have to decide whether the equation is linear or quadratic in form or informed in order to determine the solution method. So first we have to identify first whether is this equation is linear or quadratic in form, so that we can have a basis, a references on what we should use, what solutions should we use. If only number two is if only one trigonometric function is present, solve for the equation for that function. So we have to solve it. And then we have the number three. If more than one trigonometric function is present, we write the equation so that one side is equal to 0. Then try to factor and apply the zero factor property. So if we are able to if we are able to write the functions if we are able to factor it, and we have to apply the zero factor property. And then next, if the equation is in quadratic form but not factorable, use the quadratic formula. Check the solutions are in the desired interval. So otherwise, if we are not if the number three solution the number three tip is not applicable, we have to use number four, which is we gotta use the quadratic formula. And then last is try using identities to change the form of the equation. It may be helpful to square each side of the equation first. In this case, check for extraneous solutions. Okay, that's all for my report, and thank you guys for listening. Again, I am Charles Kenneth, and this is Solving Trigonometric Equations.